Assalamualaikum and hi everyone, we are from Group 9 and today I'll be introducing to you our project for BERC 1213 Programming Fundamental. Our project is the IP address classification system. So in this video, we'll explain how the system works, including how it determines the IP class, host count, subnet, IP range, and even suggest gateway network as well as broadcast address. So let's get started. This project was a team effort. We were all involved in the flowchart design and coding development. The team members are me, myself, Hasya Insyirah Binti Ahmad Hishamuddin, Harith Iqmal bin Rahim, Mohammad Faiz Iskandar bin Johari, Mohammad Eiman Zulhakimi bin Mohammad Zaki, and Mohammad Amha Fahmi bin Anuar. We each contributed to the planning of programs flow and writing the code that powers our IP address classification system. Before we go further, here's the overview of our presentation content. We'll begin with program background, followed by program introduction, and next we'll explain about our flowchart and the project scope as well as show the output of our systems. And finally, we'll end with conclusion to summarize everything. Alright, let's talk about the problem behind this project. Regarding the IP addresses, manually classifying them isn't just slow, it's also easy to mess up. Especially if you are starting things like IP classes, subnetting, or also figuring out the right range can actually feel overwhelming. And if you get something wrong, like the gateway or subnet, it can actually cause network errors as well as connection failures. And that is frustrating, especially when learning or setting up things properly. So from our experience, we realized that few tools can actually give us a simple way to check and understand the IP settings, because most of the time we have to calculate everything manually, which slows everything down for a student like us, and also for people who are already working in the field. So that's why we decided to build something that makes the process easier, faster, and also more accurate. Because of these challenges, we designed this system with three main groups in mind. First, engineering students who learn about IP addressing and subnetting for the first time, that just like us. And second, new network engineer that needs a quick tool to help with IP calculation without doing everything manually. And finally, educators that can also use this as a simple visual tool to teach networking concepts more effectively.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohammad Amha Fahmi bin Anuar. Thank you for Hasya explain about the problem backgrounds. So I will focus on scope for IP address classification system. The main objective of the IP address classification system is to develop a simple, efficient, and user-friendly application to assist in the measurement and analysis of IPv4 addresses. This program is designed to automate the classification of IP address and the calculation of basic network information to reduce the risk of human error commonly associated with manual computations. So we will focus on the IP address management program such as the IPv4. We will focus on developing a simple and user-friendly tools to help user manage and analyze IPv4 addresses efficiently. These tools automate the process of classification IP address and calculating essential network information such as the subnet network, number of usable hosts, and gateway address. Second point, one of the main functions of the program is automatic IP classification, which determines the class of the IP address based on the first octet. Once classified, the program will compute all necessary network information instantly. Third, the program uses a command line interface or CLI, which is simple and lightweight. This makes it accessible even the users without advanced technical and knowledge. It is fast, direct, and suitable for both beginners and experienced users. However, to maintain simplicity and focus, the program has a limited scope. It only supports IPv4 addressing. Next slide, introduction of our program. Number 1, project purpose. This project aims to develop a system that helps users classify and analyze IPv4 addresses using a C++ program. It reduces manual calculation, minimizes human error, and ensures network data in accurate, organized, and easy to interpret. Why it's important? Understand IP addresses is essential in network, but manual calculations are often error-prone and time-consuming. This program simplifies learning and daily tasks by providing accurate, automated IP. Lastly, the main goal of the project is to develop a lightweight, practical, and educational software tools that cater to the three key user groups, which is engineer students, junior and entry-level network engineers, and technician and educate or lecturer.
Okay, so this flowchart shows how the program process an IP address and subnet mask to give useful network details. It's especially helpful for networking students or professionals. First, the user enters an IP address in CIVL format, like 192.168.0.0. The program checks if the format is valid and if the subnet bits are between 0 and 32. If valid, it calculates the subnet mask. For example, /24 becomes 255.255.255.0. Then it checks the first number of the IP to identify the class, which is class A, whether it class A, B, C, D or E, which helps define the network type. After that, it calculates how many devices can be connected, the block size, the starting IP, based on the maximum usable IP in that range. Finally, the program displays all the results, including subnet mask, IP class, number of hosts, and IP range, on screen or in a file. So this will help users understand and manage IP networks more easily. Okay, so for the next project, explain the steps of a function called suggested gateway, which help determines a suitable gateway address based on a given IP. So the process starts when the user is asked to enter an IP address. The program then checks if the entered IP is valid. If the IP is not valid, an error message is displayed.
Thank you Faiz Iskandar for the explanation. So next I will explain about broadcast address flowchart. So the user is prompted to enter an IP address. The program then determines whether the IP is valid or invalid. If invalid, it displays an error. If valid, it calculates the broadcast address using the formula broad 1 equal to IP 0 and subnet 0, 255 minus by subnet 0, and so on. So the result broadcast address is then display of the user. So next, if you look at the network address flowchart, it's similar to broadcast process. It's begin by asking for the IP address. After validating the input, the network address is calculated using a bitwise AND operation between the IP address and the subnet mask. The calculated network then will display. So next, I will talk about overall flowchart, which is the program start by displaying the main menu to the user. It then uses a switch case condition to determine the user selection. There are 5 menu, which is number 1 is calculate subnet mask and IP profile, and menu 2 is suggest a default gateway, and 3 determine the network address, 4 determine the broadcast address, and menu 5 is exit program. So if the input is invalid, the program will display an error message and look back to the menu. For each valid selection, the corresponding function is called. The flow then checks whether the user wants to continue or exit. If the user chooses to exit, the program displays a goodbye message, write to a file, and ends.
Okay, for now I will show you the output of the program. First, when the user run the program, they will see this main menu display on the screen. It gives 5 choices, which is show IP information, suggested gateway, network address, broadcast address, and exit. And the user is asked to enter the choice by typing between 1 to 5. In this example, the user choose option 1, which is display IP information. After choosing, the program then asks the user to enter an IP address inside the prompt format. For instance, 192.198.20.5/27. Then the program processes this IP and display several details: IP address, class, host count, subnet mask, and IP range. This output helps user understand how the IP address is classified and what range IP are available in subnet. In next session, we explore what happens when the user select other options like suggested gateway, network address, and broadcast address. Now we move on to the next part of the program output. After the user select option 2, suggested gateway, the program asks for an IP address for this. And then the program will calculate and show the gateway successor, which is it will show gateway start and gateway end. This is a common default gateway address with the subnet, usually by router or network administration to route traffic. Next, if the user select option 3, network address, the program again asks the IP address input, same IP is entered. This time the program calculates network address, which is 192.168.20 and 0. This is the base address of the subnet. It's not usable by host but important for routing and identifying the subject block. Now we move on to the next. Next, the user select option 4 for broadcast address from the menu. This program prompts the user to enter an IP address. In this case, after the input, the system calculates and displays the broadcast address. This address represents the last usable IP in the subnet and is used to send a message to all devices within the network, and it helpful for communication like sending announcement or update across all connected hosts. Finally, when the user select option 5, exit, the program display thank you message. The system exits safely and better control to the operating system. This final step ensures that user has completely the interaction, confirms a clean termination of the program. Lastly, one of the most important features and one important output in our program is save to file function. Each time the user select any option from 1 to 4, whether show IP information such as the gateway, network address, broker address, the program doesn't just display the result on the screen. It also write the same output into the text file called IP classification output.txt. This file acts like a history log. It stores all the result and all the user can see, so they can refer back to it later without having to re-enter the data.
In this simulation video, what we'll do is we're going to explain our coding and how it works, as well as the function that we use in this system, and the output of the simulation. All right, I'll start with the first function, which is to calculate the subnet mask. So the first function is called calculate subnet mask. So it takes two inputs. First is subnet bits, which the number of bits used in the subnet, and then subnet 4, which also an array that stores 4 values of the subnet mask, just like standard IP with 4 octets. And then we also use 4 loops that run 4 times. So 1 time for each part of the subnet mask. So inside the loop, if there are 8 or more bits remaining, we'll assign 255 to the part. So that means all 8 bits are used. So and then we'll subtract 8 from the remaining bits. So if the remaining bits are more than 0 but less than 8, we'll calculate the partial mask by using the formula of 256 minus 2 to the power of 8 and then minus the remaining. So the given values is like 128, 192, 224, depending on how many bits are left. And then if there are no more bit left, so we'll just assign it to 0. So the subnet will be 0. So that's how the function calculates the subnet mask step by step based on how many subnet bits that we use. Next, we'll be moving on to the second part of the first function, which is to determine the class of an IP address. So the function is called getClass. So it takes one input, which the first number in an IP address, and return the class based on its value. So how it works is technically if the IP start from 1 to 126, it will be automatically assigned to class A address, and then 128 to 191 it will be class B, 192 to 223 will be class C, 224 to 239 in returns D. So this range for class D using multicast communication, and then 240 until 254 will be class E, which often used in experimental purpose. So what happened if it exceeds 254, it will be written X, which means the IP doesn't match any known class and may be invalid or reserved. So basically, this function actually uses a series of else-if condition to check the value of the first octet and identify the IP class. So this helps us to know what type of network it belongs to, whether it is for small networks, large networks, special uses like multicast or experimental addresses. So that's for the first function. So we'll be moving on to the second function.
Alright, thank you Rasha for the first explanation of first function. So now I will talk about the second function of the code, which is void IP info, which is this function display and logs detail IP address information, including class, host, count, subnet mask, and IP range. It outputs both the console and the file. So let's look at line 41, which is IP1 to IP4 represent the 4 octets of an IPv4 address. Subnet bits represent as a number of bits used for the network CIDR notation. And class IP, the class of the IP address, which is as Hasya explained before this. We have class A, class B, class C, class D, and lastly class E. And subnet in bracket 4 is array holding the subnet mask value, and a file is a file pointer for output. So let's proceed to the line 42, which is host bit equal to 22 minus by subnet bit. It's determine how many bits are available for host addressing. And for the line 43 is host count equal to 2 power of host bit minus 2. It's calculate usable host excluding network and broadcast. And for the next line is block size equal to 2 power of 8 minus subnet %8, which is find block size for the last subnet octet. And as you can see at line 45, it's base equal to IP4 minus in bracket IP4 % block size is to get the starting address in the subnet. And for the rest, 46 and 47 is minimum and maximum. It's determine the first and last usable host addresses in the range, which is for the output will print as in IP information, and the first one is IP address, second one class, the third one host count, and the third one is subnet mask, and the fifth one is IP range. So let's move on to the second function of this code.
Thank you, Iqmal, for being present. So I will explain use it function to declare the gateway and network address. So the first function, suggest gateway, is used to generate a range of a gateway IP address based on the first three parts of octet of an IP address. In most networks, in the gateway is often set to either 0.1 or 0.254. As these are standard practice for default gateway, this function takes three integer value representing the first three octet of an IP address. For example, 192, 168, or 1s, and it prints the start and end of the gateway range, such as 192.168.1.1 and 192.168.1.254. The function also saves the output into a file for record keeping or further use. So the next function, we will declare network address, is responsible for calculate the network address. It receives a full IP address and subnet mask, each in the form of 4-element array. The function then perform a bitwise AND operation between each corresponding part of the IP address and the subnet mask. This process results in the network address, which is the identifier for the whole network segment that a device belongs to. For example, if the IP address 192.168.1.10 and the subnet mask is 1.255.255.255.0, the result network address would be 192.168.1.0. Like the first function, this result is also printed to the screen and saved into a file. So for more function, I will give to Faiz for the explanation.
Thank you, Amha, for the lovely explanation. So today I will explain about the void broadcast address function. So what this program do is to count the broadcast address for the IP address that we will enter soon. So first, the command prompt will ask the user to enter an IP address and subnet mask. For the first output is the program first ask user to enter 4 octet number that make up an IP address. For example, the user enter 192.168.1.10. And so for the next command, it will ask the user for the 4 octet number that represent the subnet mask, which is, for example, is 255.255.255.0. And so for the next step is we will calculate the broadcast address based on the IP address and subnet address that have been given by the user. And the program uses a function called broadcast address column to calculate the broadcast address. So next, to calculate, the program does some bitwise operation, which is it combines the network portion of the IP with the host bits turn all to 1. And this will ensure that the address reaches every device in the subnet. So for the final step is, it will print the results on the screen and save it to output text. So for the next explanation, I will give it to Eiman.
Thank you, Faiz, for the explanation. Now we'll go to the main program, which is the main function and how the program will work in the main program. So firstly, we start with int main, which is this is the start of the main function where the program begins execution. And then we go to int choice, which is it declare a variable name choice to store the menu selection. And then for the looping, we use the do while loop. So the menu repeats until the user choose to exit. And then we go in the do while loop, we have printf, which is it will print the main menu and the prompt the user to enter their choice. And then we go to line 1 to 3, which is scanf. The function of the scanf will read the user input and clear the input buffer to prevent unwanted characters. And then we go to int IP1, IP2, IP3, IP4 and subnet bits. IP4, subnet 4, char class IP, which is it will declare variable to store the IP address, component, subnet mask and IP class. And then we go to line 130, which is if choice 1 and choice 4, it will only proceed to get IP if the choice is between 1 to 4. For the printf, it will ask the user to enter valid IP address with the subnet format. And then for the line 132, it will check the user input match the correct format. If not, it will show an error and restart the loop. And then for the file time file, it will open the file in the append mode store to store the result. And then for the if file equals null, printf and continue. It will, if the file cannot be opened, it will show error and skip the current loop. And then for the line 143, it will store the IP address into an array for easy use. And then for the calculate subnet mask, which is line 44, it will call a function to calculate a subnet mask based on subnet bits. And then for the class IP get class IP1, it will determine IP class A to E based on the first octet. And then we go to switch case break, which is it will switch to check which menu option the user select. For the case 1, if the user select option 1, call function to show and save info. And then if the user select option 2, it will call function to display and save suggested gateway. And then for the case 3, it will call function to calculate and show network address. If the user select option 4, it will call function to calculate and show broadcast address. And then after that, it will end the switch block. Okay, for the fprintf, which is line 66, it will write a divider line in the file and close the file. And then for the line 168, it will, if the user select option 5, it will show exit message. And then as printf invalid choice, please select between 1 to 5. Okay, if the user enters something invalid like 6, 0 or any characters that not 1 to 5, it will show warning message. Okay, for the line 174, while choice 5, it will repeat the loop until the user selects to exit, which is choice number 5. And for the return 0, it will end the program. Okay, for the simulation, the first thing that user can see is menu. User can select show IP information such as the gateway, number 2, number 3, network address, broadcast address, and exit. If the user want to know the information of the IP, the user can select 1. And then the user have to put the IP address, which is, for the example, 1 this /24. And then the program will show the IP information, which is IP address, the class, which is class C, house count, which is 254, subnet mask, IP range. And then after that, if the user want to know what the gateway, what their suggested gateway that they can use, the user can press 2 and then put the same IP address. The program will show which is suggested gateway from gateway start 192.168.1.1 and gateway end 192.168.1 and 124. After that, network address. The user can see the network address and the user have to select number 3, and then again the user have to put the same IP address. And then the network address will come out. After that, for the broadcast address, the user have to press 4 and then put the same IP address. And the broadcast address will come out. Okay, if the user want to check another IP address, it also can, which is select the menu first, either 1, 2, 3, 4 or 5, or 1, 2, 3 and 4 if the user want to know the IP information. And then the user want to put another IP address, which is the program also can read the input from the user. For example, and the user will know the IP information from the another IP address. And then for the suggested gateway, new address, broadcast address, also like that. Okay, for the number 5, which is exit, if the user press 5, and then the program automatically end, and it will show program end and thank you. Okay, for the save to file, how it used, after the user put the input and the output come out, the output from this program will save into the nodes, which is file txt. We can see from open the folder and then open the file, which is IP classification output. And then the user will can see the output that show in the program in the file, which is output txt. We can see IP information such as the gateway, network address, and broadcast address in the file.
So for the conclusion is the IP address classification system simplifies complex IP networking tasks, and it bridges the classroom theory with real-world application, and useful for students, educators, network admins, developers and cybersecurity teams. And it also supports smarter network planning, security and cloud integration. And last but not least is a practical solution for today's digital and connected environments. Thank you. That's all from us. Thank you.